Okay, so when we ended the last video, we were just finding FQ12. Okay, so it's going to be 5 times 10 to the negative 6 coulombs. The distance between them was 0.2 meters, and that gets squared. And so you get an FQ12 of, it works out to be negative, which just means attracting, 3.375 newtons. We're going to do the same thing with 1,3, so it's going to be 9 times 10 to the 9th Newton meters squared per coulomb squared. 1 again is 3 times 10 to the negative 6. 3 is negative 6 times 10 to the negative 6. And this time the distance between them is 0.16 meters squared. And when you type that in your calculator, you should get a 1,3 of 6.328125 newtons. Okay? So now we need to put them together. So we go back and we look at the diagram. We say, okay, so for number 1, what is number 2 doing? Well, it's attracting it. That's what that negative sign means. So there's a force from number 2 going this way. And this is 3.375 newtons. We'll need to find its x components and its y components. So this will be FQ12y. This will be FQ12x. Before we find those, we should put in what number 3 is doing to number 1. And again, it's attracting it. That's what the negative means, that negative that I forgot to write over there. Okay, so it's attracting it as well. And so it's going to be going this way as well. So this will be your 6.328125 newtons. All right, so first step, find your x and y components. X is going to be cosine. This angle here, they told us, was 54 degrees. They gave you that in the question. So FQ12x is just going to be 3.375 cosine of 54. And when you do that, you get 1.984 newtons, I believe, with more decimals, but that's all I'm writing down. FQ12y will be sine, so 3.375 newtons times the sine of 54, and when you do that one, you get 2.73 newtons. Okay? Now we need to do sum of the forces on this number 1. So in the x direction, you have 2 forces, and they're going in the same direction. So this time we're going to add them. So sum of the forces in the x direction is going to be that 6.328125 newtons that we had from up here, plus the x component that we just found, the 1.984 newtons. Add them together and get a total in the x of 8.3119 newtons, and that's going to the right. In the y direction, really easy, because there's only 1. So it's going to be that 2.73 newtons. And it is going up. Okay, so now we draw our triangle, do the Pythagorean theorem, find the angle. So we have 1 going to the right, we have 1 going up. The one going to the right is a fair bit longer. And this will be our FQ on number 1. This will be our angle. Square them, add them together, take the square root, get an FQ1 of 8.749 newtons at an angle of 18.19 degrees. Look at your diagram. It's going to be counterclockwise from the positive x. Okay? So that is number 8 done. Number 9. Number 9 is a little bit different, but you can handle it. Number 9 is the one where it has a light little ball hanging down. you bring another one near to it and it repels it. So this guy ends up being over here hanging. And it wants to know in the end, what is the charge? The two of them are charged the same. And it wants to know what's the charge. It tells us this angle is 20 degrees. We know there's going to be an Ft here. If we look at the other forces acting on it, there'll be an Fg going down. And there'll be an Fq acting this way. And you're going to do some of the forces. This Ft has two components, an Fty and an Ftx. And this angle will be 20 because of alternate interior. Okay? It also tells us in the question that the distance from the center of one to the center of the other is 2.6 centimeters. And it tells us the mass is 1.5 grams. So all you're going to do is sum of the forces in the y, sum of the forces in the x on this guy. Okay? So it's Q. So we're going to do sum of the forces in the y equals MAY. Because it's hanging there, this is going to go to 0. And so in the y then, it must be Fty minus Fg equals 0. In other words, Fty is cosine. Ft cos is equal to mg. So Ft is going to be equal to mg over cos theta. Okay? Now we go to the x. We could get a number there, but it's going to be a messy number, so I'm not doing it. Instead, I'm going to go to the x direction, and it's going to be equal to max, which is also 0. In the x direction, it's going to be the x component of Ft and Fq. So it'll be Fq minus Ftx equals 0, which means Fq is going to equal Ft, and this time in the x direction, that's going to be sine theta. So Fq is kqqq over r squared, and in place of Ft, I can fill this in. So mg over cos theta times sine theta. Okay? This is going to be q squared, so kq squared over r squared. This is going to be mg tan theta. I'm solving for q squared, multiply by r, divide by k. So q squared will equal r squared mg tan theta over k. And now fill your numbers in. So q squared will equal, r was 2.6 centimeters, or 0.26 meters squared. M was 1.5 grams, so divide by 1,000, 0.015 kilograms, times 9.81 meters per second squared, gonna run out of room, times the tan of 20. All on the top, and on the bottom is 9 times 10 to the 9th Newton meter squared per coulomb squared. When you do this, remember that's going to be q squared. You get for q squared 4.0228 times 10 to the negative 16 coulomb squared. Take the square root, and you get 2.006 times 10 to the negative 8 coulombs. Done. Okay? Only one left is number 10. This was 9. And number 10 is almost identical to 9. The only difference is, it says you start with the two balls that are charged the same, and they're 1.2 meters apart. And then it says you pick up the string. They're attached by a string. And you pick up the string at the midpoint, so the balls hang down like this. So if they hang down like this, that means this side must be 0.6 meters. Oops. And it says that they are center to center 15 centimeters apart, or 0.15 meters. So if you were to draw a line straight down here, this side would be 0.75, and now you can find this angle. And when you find this angle, it ends up being 7.175, 175 or 125, I think that's a 2. 125 degrees. Okay, just using tan. And now everything else is the same. You're going to do exactly what we just did so that you end up getting to this equation. This time, though, you're still looking for Q, but the mass is 2 grams. The radius from center to center is 0.15 meters, and the theta